In this video, we will learn how to find the area bounded by three curves. The question is, the area bounded by the curves y is equal to 1, y is equal to under root x plus 1, and y is equal to 7 minus x is options are being given. We need to find out the correct option. Okay. So what we are being given? We are being given three curves here. That is y is equal to 1. And let's try to graph this out to make more sense. So we have y is equal to 1. If we have here x-axis and we have y-axis here, okay, so y is equal to 1, it is curve is simply a horizontal line parallel to x-axis. Okay, so this is the function for y is equal to 1. Second thing, we have another function, that is y is equal to under root x plus 1. Okay, so the graph for under root x, we know it is like this, but since we have 1 as intercept, so here we have first 1 as the intercept of this first function. Now the graph of this will be like this, but we will have 1 as the intercept, so it will look like this. Okay, so this is under root x plus 1, under root x plus 1. Okay, and we have also y is equal to 7 minus x, and let's try to draw it here also. So we have y is equal to 7 minus x. Here the intercept is 7. Okay, simple thing, you can solve it for the values of x and y to get the intercepts. So the intercept is 7, and since x is negative, it will be downward sloping. So we will have this kind of function here, rather this kind of thing, so which is 7 minus x. Okay, y is equal to 7 minus x. Here the intercept is 7. We are being told to find out the area which is bounded by these three curves, that is the red, green and black curves. So obviously this area is the one which we are interested in. Okay, how do we find out the area of this very thing? First thing is, we should know this point here, because we have this kind of shape here. It is like this, then we have this straight one like this. Okay, so we have a triangular shape, and then we have this curved shape here. Okay, so we cannot say that this is a this is a triangle here. Okay, so to find out the area of that very thing, first we should know this point. Okay, so this point, so at this point we have this black curve and this green curve intersecting with each other. So we need to solve for them when they intersect with each other. Okay, so y is equal to 7 minus x should be equal to y is equal to x plus 1. So we equate these two equations first, and let us write it here. Okay, so we have x plus 1 should be equal to 7 minus x when they intersect with each other. The value of this curve and this curve is same when they intersect. Now let us solve this stuff here. So we can do one thing here. We can rewrite it as under root x is equal to 7 minus x. Transposing this here, it will become minus 1, or under root x is equal to 6 minus x. Okay, after that, what will we do? We will square on both sides. Okay, then square and root will get cancelled. We will get here only x is equal to, now what is here, we apply the orthodox a minus b whole square formula, that is a square, that is 6 square plus x square minus 2 into 6 into x. So we will have x is equal to 36 plus x square minus 12x. Solving again, and we can solve this. We have x is equal to, rather let us rewrite it in this fashion. So let's first write this x square x square. Transposing this x here, it will become minus x. So minus 12x minus x is minus 13x plus 36 is equal to 0, which is a quadratic equation. We can solve this quadratic equation by splitting the middle term. Okay, so we should get the sum of two numbers should be equal to the coefficient of the middle term, which is minus 13. Okay, and product of the same two numbers should be equal to the constant term 36. Okay, we can guess here. If I write here minus 9 and minus 4, so this is minus 9 and minus 4 is minus 13, and minus 9 into minus 4 is plus 36. Okay, solving this, we will get x square minus 9x minus 4x plus, in place of 36 I will write minus 9 and minus 4, which is equal to 0. Now we split the middle term, rather we factor the terms. So in the first two terms, let's take x common, we are left with x minus 9, and in the last two terms, let's factor out minus 4, so we will be left with x minus 9. That sums up to, and it should be equal to 0. Let's take x minus 9 common, x minus 9, then we are left with x minus 4 here, x minus 4, which should be equal to 0, which implies either x minus 9 is equal to 0, or uh, or x minus 4 is equal to 0. When x minus 9 is equal to 0, it implies x is equal to 9, and when x minus 4 is equal to 0, it implies x is equal to 4. So we got two values for x here. Okay, I'm just rubbing this out. So we got two values for x, that is, when we solved these two equations, and let's write it here, under root x plus 1 is equal to 7 minus x. When we solved this, we got two values for x, that is, x is equal to 9 and x is equal to 4. Okay, but we only need 1 point here. Now to check which of these 2 points satisfy both the curves here. Okay, so let us inspect this very stuff also. So when x is equal to 9, okay, and let us see which of these two values of x satisfy this equation. Okay, if x is equal to 9, if we take x is equal to 9 in this equation, so we will have under root 9 plus 1 is equal to 7 minus 9. So this is under root 9 is 3 plus 1 is equal to minus 2. So 4 is equal to minus 2. This is not possible, so we will not take this point x is equal to 9 here, because this condition is not satisfied. Okay, now let us see when x is equal to 4 whether this point satisfies the condition here. So if we have, in place of under root x, we have under root 4 plus 1 is equal to 7 minus 4. So under root 4 is 2, so 2 plus 1, 7 minus 4 is 3. Here 3 is equal to 3. That means when x is equal to 4, this condition is, these two are equal to each other. So we take x is equal to 4 as a point. Okay, at the point of intersection, so we got here the value of x is 4. Okay, also we need to find out this point. Okay, when this red line and black line intersect, and similar simple thing, y is equal to 1 and y is equal to 7 minus x, when we equate them, so 1 is equal to 7 minus x, which gives us x is equal to 7 minus 1, which is 6. Okay, so we got the value here 6. Okay, but we are interested in finding the area of these very two regions. Okay, remember, we are supposed to find out the area bounded by these three curves, the common area obviously. Now we can apply the definite integral here. Okay, so how do we do that very step? First I will find out the area of this whole region. Okay, then I will subtract the area of this white region. Okay, first I will find the area of this very region. So this is under root x plus 1. Okay, so if I write it here, so the area of this very region will be equal to the definite integral from 0 to 4, and we integrate this under root x plus 1 Okay, so this will give us the area of this whole region, but I need to subtract the area of this region, that is y is equal to 1. So I can subtract 1. Okay, and we integrate it with respect to dx. Okay, simple thing. I am interested in finding out the area of this very region, and if I can show it here, uh, I'm just trying to, this is like this. Okay, I am interested to find out the area of this very region. Okay, to find out the area of this region, first I will find out the area of the whole region. Okay, and let me show it here, the whole region. From this I will subtract this rectangular thing. Okay, so I will subtract this very thing. From this figure I will subtract this, then I will get the area of this very stuff. That is the same thing I am doing here. Under root x plus 1 means the area of this whole region, minus 1 dx, the area of this very region. Okay, so this minus 1 denotes the area of this white rectangle. Okay, and we integrated from 0 to 4. So we can rewrite it in this fashion, that is the integral from 0 to 4 under root x can be written as x raised power 1 upon 2. So we have plus 1 minus 1, and we integrate it with respect to x. That gives us, let us say this is the area of this region A. Okay, so the area of this region will be equal to minus x plus x gets cancelled, so we have the definite integral from 0 to 4 x raised power 1 upon 2 with respect to dx. Okay, let's take the integral now. So we have x to the power 1 upon 2, it can be written as x to the power 1 upon 2 plus 1. So using the power function rule of integral, so exponent is added by 1, so it will become 1 upon 2 plus 1 divided by 1 upon 2 plus 1, and we evaluate it from lower limit to upper limit. So it will become x raised power 3 upon 2 divided by 3 upon 2 0 to 4. We can rewrite it as 2 upon 3. Okay, x raised power 3 upon 2 from 0 to 4. Okay, I am just dragging this, otherwise these steps are not required, but for the sake of understanding I am doing this. So first we evaluated it when x is equal to 4, then we subtract and evaluate it at lower limit when x is equal to 0. So we will get 2 upon 3. In place of x we have 4. Okay, 4 is power 3 upon 2. Then we subtract and evaluate it at lower limit, which is 0 here. Okay, so we have 2 upon 3. In place of x we have 0 raised power 3 upon 2. So 4 can be written as 2 square, so I can write 2 upon 3, 2 square raised power 3 upon 2. Okay, 2 and 2 will get cancelled, and this stuff will become 0. So we will be left with 2 to the 4 to the 8, 2 to 16 upon 3, 16 upon 3. Okay, so the area of this A region, okay, comes out to be 16 upon 3. Okay, so let me write it here. When we solved this, so we got the area of A region equal to 16 upon 3. Now we need to find out the area of this very region. Okay, so here also what we need to do, we need to integrate this black function from 4 to 6. Then we subtract this white region. Okay, so let me show it here. I am interested in finding out the area of this very region. Okay, to find out the area of this region, first I will find out the area of this whole region. Okay, from this whole region I will subtract this white region. Okay, then I will get this region, that is, so here also what will I do? Let us denote it by B, the area of this very region. So we take the definite integral from 4 to 6, 4 to 6, okay, and evaluate this whole region. Okay, so the area of this very region will be the definite integral from 7 minus x. Okay, from this we subtract and subtract this very region, this white region, that is minus 1, and we integrate this with respect to x. So it will become 4 to 6, 7 minus 1 is 6. So we have 6 minus x, and we integrate it with respect to x. Okay, so let's do the integral here, integration. So we will get here the integral of 6 is 6x minus the integral of x is x square upon 2. Okay, I'm just cutting short the steps here from 4 to 6. Now we evaluate it first at the upper limit. Okay, so our upper limit is 6. So we have this 6 first. In place of x we have 6 minus in place of x again we have 6 square upon 2. Then we subtract and evaluate it at lower limit. So we have 6 here, then in place of x we have 4, then we have minus in place of x we have again 4 square upon 2. Okay, first we evaluate it at the upper limit, then we subtract and evaluate it at lower limit. So this is 36 minus again 36 upon 2, which is 18, minus 24, minus into minus is plus, 4 4s are 16 upon 2 is 8, which gives us the area of B region will be equal to, we have 36 plus 8 is I guess is which is 44 minus which is 2 which is 42. So 44 minus 42 is 2. Okay, the area of this B region is 2. Now the area, total area, let's denote it by S, is equal to the area of A region plus the area of B region. The area of A region we calculated it as 16 upon 3, and the area of B region is 2. Solving this, so 3 2s are 6, sharat shag is 22 upon 3 should be the area of the whole region. Okay, so the correct option should be D option here. Okay, so it's very simple. How do we calculate the area? First I calculated the area of this whole region, then I subtracted this area, okay, to get the area bounded by this green line and this red line. Then I find out the area of this region. Simply first I found out the area of this whole region, then I subtracted this white area to get the area of the upper region. Okay, I hope I make myself clear in this video. Thank you.